20 million years ago, the Sahara Desert was a lush tropical swamp. Geologists are now piecing together the story of the next 20 million years. Today, the Sahara lies in what is known as the Desert Belt, a region of dry air north of the equator. Here, strong winds clear the sky of clouds and dry out the land below. It stretches through the Gobi Desert in China and across the deserts of the southwestern United States. The Sahara is the largest, and yet geologists know next to nothing about when it was created.
What we have are just these little bits and pieces, these snapshots of what the Sahara was like, because the wind blows away a lot of our record, and what isn't blown away is often covered by sand, so it's kind of hard to find the rocks we need to tell the story we're trying to tell.
One of the few places that shelters a clue to the Sahara's birth is the White Desert. In this hauntingly beautiful site, dramatic shapes have been sculpted out of rock.
Oh, this is great. It's got that mushroom shape.
These structures are called yardangs, and they are a kind of hourglass that could help measure the age of the desert.
This rock is another piece of evidence that this desert was once under the ocean. It's actually a chalk made up of billions of little marine microorganisms. These chalks are actually really easy to erode, so that's one reason things are so beautifully sculpted by the wind.
But the wind is a brutal creator. It picks up sand and hurls it at the yardang.
When wind scours or sandblasts the rocks, this is the characteristic shape that we get, this mushroom shape, narrower in the middle. That's because the wind goes faster as you move up from the ground, so it can erode harder, but it has less sand in it since it picks up the sand from the ground. So where we get the most erosion, where the rock is narrowest, is where we have the best mix of fast wind and the most sand.
40 million years ago, the top of the yardangs formed part of the solid sea floor. But the wind picked up once the Sahara turned to desert, and the process of carving out these shapes began. Figuring out how long that took could help pinpoint the age of the desert.
It's hard to say precisely how long it would take for the wind to carve this all out. Something like this, about 15 feet high, soft rock, you're looking at maybe only tens to a few hundreds of thousands of years. But to carve out the whole Oasis Depression, you've got to need at least 1 million years.
But geologists suspect the Sahara is older than 1 million years. In their search for a more accurate date, they next turn to its most iconic feature: sand dunes. Here in the Sahara, sandstorms kick up that can last for 4 days. The sand is hurled across the terrain. Over hundreds of thousands of years, it accumulates into dunes that can tower 50 stories high. Perhaps these mountains of sand hold the secret of the desert's great age.
As soon as the climate becomes arid, you can start building dunes. And if we want to know how long that took, we can try and date the dunes themselves, but that's really hard.
What's hard is that these dunes are constantly shifting. The wind that builds them also blows them away, moving them an average of 50 feet a year. To get a precise age for the desert, scientists need to follow the sand to the end of its journey.
Coarse sand travels slowly and doesn't go all that far, but the finer particles will actually travel further. And so dust-sized particles actually can get carried out into the Atlantic.
The Sahara is the largest source of dust on the planet. 500 million tons of it ends up in the Atlantic every year. Some of it reaches as far as Florida and creates spectacular red sunsets. But much of it settles on the ocean floor, a treasure trove of information about the Sahara's past.
What's wonderful about working with the ocean sediments is that they capture everything. They're this very faithful recorder of the sediments that are raining down from the surface.
In 1995, Domenical drilled down into the ocean floor through layers of mud dating back millions of years. Each layer of sediment is like a time capsule. Shallow levels show plenty of this dust blown over from the desert. So Domenical extracted deeper core samples from over 1 million years ago. Still, there was desert dust. Finally, he dug down to a layer that was laid down 3 million years ago, and there, the dust finally stopped. It had taken a voyage to the ocean floor to uncover the turning point from humid tropical landscape into searing desert.
That's a pretty amazing change. You don't think of something as large and expansive and fixed as the Saharan desert as being something capable of such profound changes. And yet this is what the geologic record was telling us.
Domenical had finally solved the riddle of the sands. The Sahara has been a desert wasteland for 3 million years. In the search to discover the age of the Sahara, geologists have unearthed 2 startling clues. Yardangs show that wind-blown sand has been blasting across the desert for at least 1 million years. Deep-sea cores give a more exact date. The Sahara first turned from swamp to sand 3 million years ago. From that moment on, the Sahara became the searing wasteland we see today.